Hey Computational Thinking, Tennyson here, and we're going to do some code review. Now for this video I decided I'm just going to put together all the code review in one video and then put some timestamps in the YouTube video. That saves me some time. It makes it more likely that I'm going to do homework review on time. I'm sorry that I don't do homework review on time. I'm working on it. There's a lot to do, but that's no excuse. Alright, I'm going to be hanging out down here for the rest of the review. And so let's just go ahead and get started. For number one here, this is a while loop. Run the code. Observe that this is an infinite loop. All right, let's observe it. Oh my gosh, infinite loop. All right, change the code inside the while loop so that x goes up rather than down to fix this problem. If you take a close look at the code here, you can see that x is going down, right? We're subtracting 1 from x every time. Let's add 1. Yay! Okay, now this has multiple outputs in it. Remember, you can always press this little button right here. I'll zoom this in a bit so we can see better. We can... Alright, we can run this code again, go all the way to the top, check our output, see that it stops at 10. Now, you might be wondering, why does it start at 2, not 1? Well, notice that in this code, on line 5, you're adding 1 to 1 before you print it off. So, naturally, the first thing to be printed is 2. If this started at 0, it would go from 0, or excuse me, it would go from 1 to 9, at least in the output, right? What we actually see. Remember that what we see is different than what variables contain sometimes. All right, number 2, run the code. This would also be an infinite loop were it not for the break statement. This is an observation, right? So we're going to see that x is equal to 1, and while x is less than 10, we'll subtract 1 from x, just like we were doing in that infinite loop before, and then we'll print it out. However, once x is equal to negative 100, we'll say x has reached negative 100, and there we go. The break is what stops the while loop from continuing to go. Number 3. Add code to this while loop so a user can type in quit and stop the infinite loop. Okay, so that's pretty simple. When we have to ask a question about the code that we're getting from the user, we need an if statement. So we'll say that if user command is equal to quit, then we will break. Simple as that. We'll run our code again. Down here we have a little input, if you can see it, and I'll just say quit, and we'll break it, and then we get to move on to some other code. All right, I'll clear this out. Number 4, notice that the print statements on line 32 and line 33 still appear after this while loop runs, even though the condition on line 27 technically becomes false on line 29. Right? So we're saying that Frodo starts out as visible, and then we set Frodo to be invisible. But the for loop, the while loop continues, even though the condition is while Frodo.lower, right? So just the lowercase version of whatever Frodo is, while it's equal to visible, keep the loop running, but it becomes invisible. Right? Well, that's obviously different than what this condition wants, so you think it would become false, but it does not, because it doesn't become false until we return to the top of the while loop. Right? Code runs in sequence. So lines 40 and 41 are going to continue to run even though the condition technically will become false very, very shortly, right? But we're only changing the data here. We haven't reached the condition. We haven't gone back to the condition for the second or the next loop. Okay, so yeah, code still runs right there. All right, unless of course we use a break, and in this case we are using a break to accomplish what it is we maybe set out to do, and that's that once Frodo becomes invisible, we want to do something different. So in that case, we're going to print out Frodo, you idiot, because he shouldn't have put the ring on. It wouldn't have caused so many problems in the first place. We'll break, right? And at the very bottom, we get this last print statement, right? Let me go ahead and quit there. Okay, so when we break the loop, right? When we break this loop, notice that we don't ever hit this, right? Because this is after the break. So if we hit the break, we're not going to get this last line of code because it's in the while loop. If we just tab that over by 1 and we run this code again, you're going to see that now we get that print statement, right? Frodo, your weakness is inevitable. Okay, that's 6.1. Let's move on to 6.2. First problem for 6.2 is generate a list of random integers between 1 and 10 using a while loop. If I'm going to do anything with random, I need to import it. That's why you got to watch those videos. Okay, so random integers between 1 and 10 using a while loop. Start by building an empty list to hold the integers, okay? Empty list to hold the integers. What a variable name. Okay, so we're going to say let's see, while the length of our list, and you can do whatever you want to here. Actually, let's make this a little shorter, because that's going to get aggravating to type that again and again. Ints. There we go. Cool. While n of ints is going to be less than 10, we're going to say ints.append random.randint 1 through 10. Okay. Ints. There we go. So what we're doing here is we've got our empty list. We are governing our while loop with this condition. You can make it whatever you want. We're just building some list of random integers between 1 and 10. And then we're appending a random integer between 1 and 10 every time that the loop runs, right? So random.randint returns a value between 1 and 10, and it appends it to ints. Okay. Generate a list of random integers between 1 and 10, but do not include 3s or 7s. You'll need an if statement here in addition to the while loop. So easiest way to do this is we'll say ints2. That's going to be same kind of pattern here. We're going to say while when ints2 is less than 10, we're going to append. Now what are we going to append? Well, we're going to append another random.randint 1 through 10. All right, but we got this new condition, or this new problem, right, where we don't want to include any 3s or 7s because this list does not approve of 3s or 7s. Okay, so what we need to do actually is take this out of here. We don't want that. And we're going to need to put it up here. So we're going to say gen value, or generated value, is random.randint 1 through 10. Maybe I can make that even clearer. I could just say random value. Okay. All right. So now we can say if random value is equal to, or if random value is not equal to 3, and random value is not equal to 7. What can we do? Well, we can append it to ints2. Okay, there you go. Otherwise, we don't do anything. Now, you could say like, oops. You could say, you know, else 3 or 7 detected. So we don't do it. And let's see, we get ints2. There you go. No 3s or 7s in there. A lot of 2s, though. Very high frequency of 2s. What are the chances? Okay, this makes sense. Now, we can't say this, right? The reason we can't say or is because, remember that and creates a situation where both statements must be true. Both conditions must be true in order to meet that and requirement and move on to this line of code on line 18. However, if we're running this code and we've got an or, well, what could happen is if this one is true, like if it's 7, which means it's not equal to 3, then we get what's called a short circuit, right? Because this is true in that situation. So if random value is 7, that means it's not equal to 3. So Python's just like, oh, okay, well, I don't have to worry about any of this other stuff because this is true. And any true in an or automatically makes the whole condition true. So we're going to go to line 18. So you got to use the right operator there, and it's and. Okay, moving on. Using the list of names below, build 3 groups of students chosen randomly from the list. Use a while loop to do this more efficiently and avoid repeating yourself. Make sure you don't have the same student in 2 groups. Pop or remove all your friends here. Okay, so I'm going to show you what I think is the most straightforward way to do this. How many groups did I say? Build 3 groups. Okay, so group 1, group 2, group 3. Now, so I can say that I can keep this loop going and keep adding random people to these groups in a couple of different ways. So one condition I can do is this. So I can say while the length of names is greater than 0, I can keep going. Okay? That works just fine. So that means there's something in the list, right? For a list to have a length, there has to be something in there. So let's see. Easiest way to do this is probably like this. Group1.append random.choice names, right? So that's going to make a random choice from... Actually, hold on. We need to do one more thing. We need to say, all right, random name is random.choice names. Okay, so we get a random name, and then we say group1.append random name, and we need to remove that name from our list of names. So we say names.remove random name. Now, you're going to have to do this for each group, right, until we run out of names. So one way to think about this is to change the variable name and just say random name 1, random name 1. So we have some differentiation here to make this a little bit easier to understand. And then basically we can copy paste this and say, all right, this one, and this will be random name 2, 2, 2, 2, 2. Oh, not 2. This one's 3. So random name 3. Okay. And this is going to go to group 2. This is going to go to group 3. All right. Now that's very repetitive, right? So maybe that's, you're thinking like, oh, it's very repetitive. Maybe I can do something about that. And you're right. You can. So I've got this code. And if I run this code, all right, if I look at group 1, that looks good. Group 2, and then group 3. So the issue is that I run this code and group 1 actually gets the very last, it gets that 10th kind of odd one out student, but then the rest of my code doesn't work, right? Because I can no longer make a random choice from names because the list is now empty, okay? So what you can do, one thing you can do to solve this problem, and this is complex, like this is definitely one of the most complex homework problems I've given you. So if I say if names, right, which basically will check, or I can say if the length of names is not equal to 0 at this point, then do this, right? I can make that check here. I can also say this, and another one, this is another one I wanted to point out. I can say while names and if names, and this does the same thing, because an empty list of names is falsy. We talked about that, like an empty list is falsy. So I can also say this, it's just shorthand, but I'll go back to the old way. Okay. So if len names is not equal to 0, then I can still do this, and I would have to say the same thing for this one right here. Now this is some very like hard-coded, you know, it's only going to work for this particular case kind of thing, and that fixes the problem, right? So group 1, group 2, group 3, no errors, right? But this is a little bit repetitive. So what I want to show you now is a more efficient way to think about this code. And it involves the use of a function. Now, we didn't talk about functions before this homework, so obviously I don't expect you to realize this, but hopefully in doing the repetitive process, you realize the benefit of functions when you see this. So if you recall, we had you know, this whole set of repeated code before, right? And when I see repeated code like that, it makes me personally think about functions, and hopefully eventually it'll make you think about functions too, because that's what we use functions for, is to avoid repeating ourselves. So I'm going to define a function called addRandomStudent. It's going to have two parameters, the group that I'm adding a student to and the list of names that it's drawing students from. And the first thing I want to do is I want to check and see if the length of names is not equal to 0. That means I still have names to choose from. The first thing I'm going to do is get the random student, just like I did before. So not much of the code is going to change. I'm going to make a random choice of names. I'm going to append that random student to, or excuse me, not group 1, but group, which you'll see how that works in just a second. So group dot append random student. And then we're going to remove the random student from names. There we go. Okay. Now that I've done that, I can come and call this function called addRandomStudent, starting with group 1, names, addRandomStudent again with group 2, names, and then addRandomStudent the last time with names. Now that's quite a bit more organized, and it makes sense to some extent. Let's run it and see what happens. Group 1, group 2, group 3. No repetition. Everybody's in a group. No errors. Names is now an empty list. So this works too. That's the power of functions, removing repetitive code. So take a look at that, understand it, and then hopefully that'll give you a better idea of what we're going to be doing with functions. All right, here we are for homework 7.1. So these are all for loops that we're working with. A lot of these are observations. So this first one, we're going to run it. we see that we have a list of cars, and for every car in cars, we're going to print out that car plus the phrase goes vroom, and that seems to work correctly. We're going to go ahead and comment this out with a control/. Move on to our next one. It says to uncomment this out and observe its behavior. So let's take a look at it. It's got the same, oops, okay, there we go. So it's got the same kind of list here of cars, and we'll say for a car in cars 2, if a car is a Geo Metro, print that one goes putt-putt, otherwise they go vroom. Okay, so that looks, there you go, observing that one. Every time I loop, every time I iterate, that variable represents a new element in my list. All right. Okay, uncomment this one and observe it. So with this one, I'm using modulo, which gives me the remainder of a division operation. So basically, I'm looking at all the odd numbers here. So of course, for num in nums, if num modulo 2 equals 0, well 1, which is the first num for our first loop, if 1 modulo 2 is not equal to 0, it's equal to 1. 1 modulo 2. Okay. I'll print, so I'm going to print out odd number detected plus that number. So I get 1, 3, all my odd numbers are here with the odd number detected. Otherwise, this if condition is met. So 2 modulo 2 is 0. 2 modulo 2 is 0. 4 modulo 2 is 0. 6 and 8. So as I loop through, those become 0. That evaluates to true because those values modulo 2 are equal to 0. And so I print out just the number. All right, cool. Commenting that out again. All right, this one, write a for loop that prints out each name in the names list concatenated with the string stored in the variable important message. Example, the first string should be Alan is the imposter. So it's pretty straightforward. So I'll say for name and names, print name plus important message. Important message. There we go. Let's see what happens. Aha! There we go. Several imposters. All right, number 5 here. Write a for loop that prints out each number in the more nums list multiplied by 3. Okay, so it prints out each number multiplied by 3. So I'm going to say for num in more nums, print num times 3. It's as simple as that, okay? So num represents each value. It represents one value per loop, right? Num is 9, and then it is 18, then it is 27, 36, 42, 45, all in all in sequence as the loop runs. So there we go. Each number each number times 3. That's what it looks like. And for the last one, write a for loop that squares every number in the small nums list and then appends it to the big nums list. So this is kind of like the filter pattern. We're going to say for num in small nums. We'll say big nums dot append num to the power of 2. That's squaring. All right, and then we can take a look at big nums once we run our code. We get 4, 16, 36, blah, blah, blah. Okay. The other way to do this, which isn't really that different, but you could just say num squared is num times 2, and then append something like num squared. And that might be more readable to you. There's one more way to do this, and that's writing a list comprehension. So we can actually drop all this right here, and we can simply say that okay, this will accomplish the same thing. It's working. I don't know why this is broken now. Maybe I'm just going too fast. Okay, that's 7.1. Let's move on to 7.2. All right, for 7.2, you're going to be working with range. And range is the computational thinking example of for a set number of times rather than for every item in a set, which is what we were doing before. So we're going to observe some behavior. We see how it works with range. We get from 0 to 9, but not including, or excuse me, we get from 0 to 10, but not including 10 over here, right? This is equivalent to this, does the exact same thing. If we wanted to get 0 through 10, we would have to say 0 through 11 if we wanted to actually print that out, right? Or store it in a variable, whatever you're doing with that. Okay, so we're going to comment this back out. We'll uncomment this code. And it's going to do something very similar, except it's just going to square every value. So we get 0, 1, 4, 9, 16, 25, etc. Pretty straightforward. All right, we're going to uncomment this code. See what happens here. So this one, right? This one runs a for loop, but this time we've got this stride. So it's counting from 0 to 10 by 2. And then each time the loop runs, we have this little set of print statements. We're saying number is 0, right? And then we're saying number 0 to the power of 2 is 0, number 0 to the power of 4 is 0, so on and so forth, right? And we can come in here and we can adjust all this good stuff. We could start it at 2, count by 2 up to 100, and that gets some crazy numbers really fast, right? So we get 98 to the power of 8. Wow, that's a lot, right? That right there is, let's see, 1, 2, 3, 1, 2, 3. That's 84 million. 96 to the power of 4 is 84 million. Holy cow. Okay. Comment it back out when we're done. And let's see. So print every number 0 through 50, not including 50, multiplied by 2. Pretty straightforward. For I in range 0 to 50. Print I times 2. Boom. There you go. 0 to 50. I times 2. We can even clear the shell to get a better look there. Okay, there we go. Print every number 0 through 50, counting by 5. So we need our stride, the optional stride argument here. 0, 50, by 5, print I. There we go. Now we're counting 0, 5, 10, 15, 20, 25, etc. And then lastly, using the two lists, append every value at an odd index to the odd indexes list. You will need the modulo operator. Okay, so this one's pretty interesting. Let's do this. We'll say nums is a range from 0 to 40. All right, so let's take a look at nums. Now let's just do for num in nums, print num. Let's just take a look around at this code first. All right, so we're going to print this out. Actually, I'm going to go ahead and comment these guys so I'm not so confused about what's going on. And we'll just have this output. So I get every value between 0 and 40. Looks pretty good. Now, let's do this. Let's print out, let's just take a look at something else. Let's see what the list version of nums is. All right, so this is, we're going to append every value at an odd index. Okay, so the numbers at odd indexes are 1, so this is 0, index 0, this is 1, so 1, 3, 5, right? So this is basically just the odd numbers. All right, so how can I find out what the index is? Well, I could say I is 0, and then for num in nums, right? I start out at index 0, so I'm going to say nums, and I'll say nums I. Let's just print out nums I. This is, I mean, this is basically doing the same, exact same thing. Okay, so that's giving us 0 every time. So if we say I is I plus 1, now we're going to get all these values, right? We get up to 39. So it's basically doing the exact same thing. I is just representing the index this time. So now I want to say, all right, if I modulo 2 is equal to 0, that's going to be an odd index, right? Then I'm going to odd indexes dot append nums I. I can do this, and this will work. So this should just be the odd indexes. Oops, I forgot to add. I forgot we're supposed to do I equals I plus 1 every time. All right, there we go. All right, odd indexes. Okay, not quite right, not quite right. So if I modulo 2, oops, not equal to 0, not equal to 0. Because if it's I modulo 2 equals 0, that's going to be all the evens. So now it's good. There you go. Okay. You don't really need this I, though. You can actually just do this. You can say if num, because we're basically the range is the same thing as it's the range is the same thing. There we go. Still works. Cool. So there you go. That's 7.2. Hopefully this homework review is helpful. You know, as we move on to functions, you're going to be checking your own code a lot more using PyTest, but we'll still do some homework review. So don't worry about it going away, and I'll try to be more on top of it.